Good morning, guys. We're going to talk about acceleration today. And acceleration is the rate at which velocity changes. So you have speeding up, that's positive acceleration. Slowing down is negative acceleration. And then we have changing direction. If you remember, velocity is the speed and direction. So if you're changing velocity, changing direction will also be considered acceleration. An example of that would be if you're driving down a curvy road and you're not changing your speed, you have cruise control on. So that would be also an acceleration. The symbol for acceleration is A, and the units for acceleration is meters per second squared. Now, don't let that confuse you because of the squared. You're not squaring any of the numbers. That's just the unit. Okay, so you don't square any numbers just because it says meters per second squared. Okay, so constant speed or velocity means your acceleration is 0 meters per second squared. So if you're at rest, your velocity or speed is 0 meters per second because you're not moving. And because you have no velocity, you're not going to have any acceleration either. So your acceleration is 0 meters per second squared, or you may also see it written like this, meters per second second. Okay, so let's do some calculations. The acceleration formula, if you have velocity, is acceleration is the change in velocity over time. If you're wanting to find distance with acceleration, it's 1/2 times acceleration times time squared. So at this point, you will be squaring time only. Then to find the change in velocity, you're taking the final velocity minus the initial velocity. And we'll see how that goes in just a second. Okay, so here's our first example. As you throw a baseball, its speed changes from rest to 5.5 meters per second in 0.75 seconds. At what rate did the baseball accelerate? Okay, so we're looking at, we've got our acceleration formula because we know this is right because it gave us velocity and it gave us time. So this is the one we're going to use. Your change in velocity, if you're going from rest, that means that you are at 0 acceleration or 0 velocity. You're moving to your max velocity is 5.5 meters per second. So that's why you have the final minus the initial. And it's not always going to be from rest, so be careful with that. All right, now that you have your change in velocity, your time is 0.75 seconds. So you do your calculations and you've got 7.33 meters per second squared. Now let's do another one. During that acceleration in the previous problem, how far did the ball travel? So if we're saying how far, that means we're looking for distance. All right, so you have distance equals 1/2 acceleration times t squared. So 1/2 on your calculator is 0.5. And then your acceleration from the previous problem is 7.33 meters per second squared. And then you have your time, 0.75 seconds, and you're squaring only time. And you do your calculations and you get 2.06 meters. So that's the distance the ball traveled in the previous problem. Okay, so if you catch the baseball, you slow it down in 1.5 seconds. If it decelerates or slows down at 5 meters per second or 5 meters per second squared, how fast was it moving? So that's one that you can do on your own. and see how you can do with that. I want to do some of the practice problems. This is on documents on RenWeb. So this is going to be your assignment, but I'm going to do the first two for you so you can kind of see how it goes. So we're going to look at what is the acceleration of your car if it can go from rest to 26.8 meters per second in 6 seconds. Okay, so there's a couple of things you need to do here. If you're going from rest to 26.8 meters per second, you have to find your change in velocity. So your initial velocity is going to be 0. Your final velocity is 26.8 because from rest to 26.8 meters per second. So you're just going to do your calculations, and because that's 0, you're going to end up with a change in velocity of 26.8 meters per second. Okay, now the second part of this, you're trying to find acceleration. So now that you have your change in velocity, you can calculate acceleration. So your change in velocity is 26.8. We just did that. And the time is 6. So that's 6 seconds right here. You do your calculations, and your acceleration is 4.47 meters per second squared. Now, number 2, it's related to number 1. It says, how far would the car in the previous question have traveled during the 6 seconds? So again, you've got distance is 1/2 acceleration times time squared. So your distance is your 1/2 is equal to 0.5. Your acceleration is 4.47 meters per second squared, and that was in problem number 1. Your time is 6 seconds, so that's going to be 6 squared. Then do the math, and you've got distance equals 80.46 meters. Okay, so if you have problems with that, let me know. Send me a remind message. But I do want you to do the problems on that I have on the documents. So it would be the acceleration practice problems. And you're going to do that. The deadline's on RenWeb. I think it's tomorrow afternoon. But double check me on RenWeb and do what I have there. So again, if you have problems, let me know and do some math. Talk to you later. Bye.